Question 10. Now, to find an equation for L2, we're going to need to know two things. We're going to need to know a point on the line, which we do already, 3, 7, and we're also going to need to know the gradient of L2. Now, L2 is perpendicular to L1, so if we can find out the gradient of L1, we can just flip it over, change the sign to get the gradient for L2. So, just looking at L1, we've got the coordinate 0, 2, and 3, 7 are both on L1. So if we just pop the triangle in there, that's giving us a base going from 0 to 3 of 3, and a height going from 2 to 7, which is 5. So the gradient of L1, y step over x step, is positive 5 over 3. So our gradient of L2 is minus 3 over 5. So we've got a gradient, minus 3/5, and we've got a coordinate, 3/7. So we can now work out the coordinate of L2 using y minus y1 equals mx minus x1. So substituting in our coordinate 3, 7 and our gradient, multiplying through by 5 and then multiplying out the right hand side by minus 3, we get this, which simplifies to this, which is the required format of ax plus by plus c equaling 0. Now for part B, we've got to work out the exact coordinates of r. Well, we know r lives on the line L2, and we also know that the y coordinate is going to be 0. So the y coordinate is 0, so 3x minus 44 is going to equal 0, so 3x equals 44, x equals 44 over 3, so the coordinates of r are 44 over 3, 0. Now we're being asked to work out the exact area of the quadrilateral ORQP. Now the easiest way to do that is going to be to work out the area of the triangle OSR, and then take away the area of the triangle PSQ. Now the triangle OSR is going to be alright to do. It's just going to be half times base times height. So our base is going from no, that's not what I'm doing. I'm going to do, we can do, yeah, we're going to do, but we're going to think about it as the base is from O to R, which is 44 over 3. Okay, because it's the okay, it's going from and then obviously the height is what the coordinate of S is, and the coordinate of S we haven't worked out yet, but we know S lies on the line L2, and it's when x equals 0, so substituting 0 into L2, we get the y coordinate being 3 lots of 0, add 5y minus 44 equaling 0, so we get the y coordinate being 44 over 5. So back to finding the area of the triangle OSR. The base is from O to R, which is the length of 44 over 3. The height is 44 over 5, so half times 44 over 3 times 44 over 5 is 468 over 15. Then we've got to take away the area of the triangle PSQ. Now here we're going to have a actually what we're going to do here, you've got to be very careful here. We're actually going to have SP being the base, so that's going from 44 over 5 down to 2. So that's a length of 34 over 5, just so we're clear on that. That's the length SP, and then we're taking this perpendicular height here. We're going across horizontally from the y-axis across to Q, giving us a perpendicular height, if you're looking from the side, of 3, because the x-coordinate of Q is 3. So we haven't gone and done it the traditional way of trying to work out half times PQ times QS. That is not what we've done. We've done half of SP times the horizontal height from the y-axis across to Q. So again, just running over how we worked out the area of PSQ, that's half times the length SP, which is 44 over 5 take away 2, 44 over 5 take away 10 over 5, which is 34 over 5, and times the length from the y-axis, the horizontal length from the y-axis to Q, which is exactly 3. So the length, so the area of the triangle PSQ is 51 over 5. One take away the other, we get 815 over 15, which simplifies to 163 over 3.